All right, here we need to simplify the expression, so it's all about counting the factors. I've got the cube root of 125 y to the 6th. So what I've really got is I've got the cube root of 5 times 5 times 5, which is 125, times y times y times y times y times y times y. That's what y to the 6th means. So I look to see how many groups of each thing I can pull out. There you go, one group of 5, so I can write 5 out in front. I've got one group of y, so I can write y again, and then I can write one more group of y, so I have 5 times y, and nothing left behind. If there was, say, maybe a z, I would leave the z under the cube root, but I've got nothing, so I don't have to write the cube root of anything. Cube root of 0 is 0. Then I just need to put this together, and I have 5y squared. Alright, so next, what we have here is basically the square root, right? 1/2 as an exponent means the square root. So I might rewrite that because to me it's a little more intuitive to have the square root. So I have 9u squared v to the 10th. Well, I know that the square root of 9 is 3, but I'm going to rewrite this thing just to make my life a little easier. Times u, because it has u squared, so that's u times u. And then I have v to the 10th. Now v to the 10th I could write out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I say, alright, square root of all that. Well, we've got one group there, pull out the 3. One group there, pull out the u. 3 times u. Times. We've got 1 pair, 2 pair, 3 pair, 4 pair, 5 pairs of 2 v's, of 2 v's. So we have v times v times v times v and times v. One v outside the square root representing all of our v's underneath. So we end up with 3u v to the 5th. And no square root because there's nothing left behind. Somewhat slightly simpler way maybe to do it than having to write all of that out is just look at the number of factors. Well, square root of 9 is 3. But for v to the 10th, it might not be that obvious. So what you can do is you can take whatever exponent this is and divide by what the index is. Okay? And so whatever that number is what you put out in front, and the remainder, if there would be, let's say this was 11, v to the 11th, and we had the square root of v to the 11th. Well, 11 divided by 2 is going to be 5, so I know v to the 5th came out. But the remainder would be 1, so there'd still be the square root of v to the 1st left behind. Okay? So that's another way to think about it. You can write them all out. If that makes more sense, I'm okay with either. Alright? Alright. Here, what we've got going on is we've got the 4th root of x to the 4th in letter C here. So really we have the 4th root of x to the 4th over the 4th root of y to the 8th. Now, again, I could write these factors all out, but I've got the 4th root of x to the 4th. That's just going to leave me with an x. It's undoing it. It's like taking the square root of x squared. Underneath here, remember what I said? I said you could take this exponent here and divide it by the index that's out here. Well, I'm going to do that in this case. So 8 divided by 4 is 2, and there's no remainder, so I don't have to have any root left over. So I just have y squared, and I have my answer. Okay? Alright, here's where it gets a little bit trickier. First things first, I need to get all of my exponents to be positive. So I have to rewrite this as 6x, y to the 1/2, z to the 5th, over 2x to the 1/3. I also want to take a look at this and try to see where where I can simplify things. Okay? Well, 6 over 2 is 3. Alright, and then we have x to the first over x to the 1/3. So that's going to be x to the 1 minus 1/3. We still have y to the 1/2, and we have z to the 5th. So I end up with 3x to the 2/3, y to the 1/2, z to the 5th. I guess that wasn't so bad after all. Okay, so for this slide here, we're going to be counting factors, especially underneath the radical. So 5 underneath the radical only has a power of 1. So the 5 is going to stay. So first things first, I draw my radical, 5. And the 5 goes underneath. So I have the 5th root of 5. Then I look at a. And a has the power of 5. So then I take 5 and I divide it by our index, which is 5, and I know I've got a 1. So a to the first stays out in front. Then you've got b to the 9th. B to the 9th, so we take 9 divided by 5. 9 divided by 5 is 1, so b to the first is going to come out. The remainder from that is 4, so we've got b to the 4th staying behind. Then we take c to the 13th. Well, 13 divided by 5 is 2, so c squared comes out in front. And then the leftovers would be c to the 3rd, because the remainder from that would be 3. So you have ab c squared, 5th root of 5, b to the 4th, c to the 3rd. Alright, now for b here, it's similar in a lot of ways. We take cubed root of x, and we separate cube root of y to the 7th. Well, cube root of x has a power of 1. I can't do anything with that. But cube root of y to the 7th, I take 7 divided by 3 is 2. So I go, oh, y squared is going to come out. Then I have the cube root of y, and over top the cube root of x. Now here's the issue. Normally with square roots, we just multiply by the same square root in order to rationalize the denominator. But now we need 3 versions of y underneath the radical. So in order to do that, I've got y to the first, so I need this exponent underneath to be a 3. So when I multiply and rationalize the denominator, I need the cube root of y squared and the cube root of y squared, not just the cube root of y. Because once I multiply these two things, here and here, they're going to end up with a y to the 3rd. And so you have to make sure you account for that. So my new answer then is the cube root of x y squared all over y squared times my y now, because I ended up with the cube. Well, I'll write it. We'll have the cube root of y cubed. Well, the cube root of y cubed is y, so we simplify cube root of x y squared over y squared times y, which equals the cube root of x y squared all over y cubed. Okay? But the key was, when I go to rationalize, I look and I say, well, there's one exponent there. And it's, the 1 is the exponent there. I need that exponent to be a 3. Because I've got a 3 in the index. So I take the cube root of whatever would get that to be a 3 and multiply it, top and bottom. Okay, so y squared times y to the first is y cubed. So I have the cube root of y squared multiplied. Alright? That's rationalizing when it's not a normal square root.